Hey guys, welcome back. In this video, we are going to discuss about implementation approach for linked list. As we have already discussed, we are using node type to store the element in the linked list, right? Each and every node will have two parts within it. One is actual data and another part is reference or pointer to the next node. Actual data means whatever data we are going to store in the linked list, that specific type. Here I have created one node type which is having two attributes within it. One is actual data, which is int type. I'm going to store int values to this linked list. So I'm just using int type and reference. This will be another node. That's it. And it's having one constructor. So whenever I create object for this node class, it will expect one integer value. If I pass that integer value, it will be assigned to this variable and next value will be null by default. Let's go for linked list class. Here I just created one method for insert element in the linked list, and I have created another method to delete the element from the linked list, and I have created this method to display what all elements we have it in the linked list. And this is my main method of this class. Whenever I execute this program execution will start from this method. Alright, when I execute this program, first this line will execute. Here I am just declaring one linked list. That's it. In the second line, I'm just inserting one element to this linked list, which is 4. And next I'm adding element 1 and I'm adding 3 and I'm adding 8. So totally I have added 4 elements to this linked list and just printing that. So it will print 4, 1, 3 and 8. And next I'm going to delete element 1 from this linked list, which is this element. After I'm removing this element, I'm just printing this. Means it will print 4, 3 and 8. This is what we expected, right? Let's run this program and see what is happening. After inserting everything, I'm just printing all the elements, which is 4, 1, 3 and 8. This is what we expected. And next is deleting element 1 from this linked list. Deleting 1 from the linked list. 1, it's found, so it's deleted. After deleting this 1, right, we will have only 4, 3 and 8 from this linked list. Alright, let's run this program in debug mode so that we can understand what is happening in step by step. I'll just put some breakpoints here from the starting and what is happening in the insert method, right? To that I'll just put one breakpoint in insert method. Same thing we have to do it for delete method. That's it, right? Okay, let's run this program in debug mode. Whenever I execute this line, it will create one object for linked list class. It will not have any element by default within it, right? This is just having 0 elements. I'm going for next line. In this line, we are going to insert element 4 to this linked list. Here in this insert method, we are just passing empty list, which is we have created earlier, and I'm passing 4. Basically, we wanted to add this element 4 to this linked list. If I click next line, it will go to insert method. Here we are just sending empty list and data will be 4. Here I'm just creating one node with the type of data, which is 4. Actually here the expectation is I'll just draw that in nodes. Whenever program executes this line, what will happen, right? It will create one node with value of 4, right? This is what will happen in this line. Here we are just assigning null to the next. This will be pointing to null, right? Now we know that every linked list will have only one head node, which is first node will be the head node, right? So since this is the first element in our linked list, we should represent this node as the head node, right? For that I'm just checking this list already having any head node. If it is null, which means it doesn't have any head node, I'm just adding this node as the head node, right? When I'm executing this line, this head will be null, so it will go inside this if block. So whatever new node we are creating, this node, basically this node going to be treated as a head node. That's it. Just we are returning this node as the first element. So after executing this line, this first node will be the head node. That's it. We have added the first line, right? We are going for the second line now. So now we have this data in our linked list. Now we are going to insert element 1 to this linked list. Basically what we have to do, right? We have to create one node. It should have 1. Now another thing we have to do is we have to point our previous node reference to this current node. This is what we have to do, right? Let's see what is happening in program. In this list already we have one element, that is head node, which is having data 4, and next reference will be pointing to null, and this is what our data we are sending 1. Okay, now we have created one more node, which is this node, which is having data of 1 and next will be null. Okay, now here this condition will be false because in this linked list already we have the head element, right? So this will not be a null. In this head we will have some information, right? So this is not null, so this will not be true anymore. So it will skip this if block. It will go to else part of this if. Here if head node is there, we are just assigning this head node to this new variable called node. So this last node will have the head node information. This head node having any next value, which means this head node having any next. In this situation we don't have any next, right? Means we haven't point any node to this node, so this will be false. It will skip and it will go to here. Our new node will be assigned to this next, which means this new node will be assigned to this next. Got it? Now we have two elements. First element is our head element, which is holding 4, and the first node next will be pointing to this second node, which is holding value 1, and this second node reference of next will be pointing to null. Clear? Right. We have added two elements in the linked list, so this is what we have. I'll just clear it. Now we are going to add third element to this linked list, which is 3. So already we have two elements. This is head node. This head node reference will point to this one. Now this one will be pointing to null as of now. After adding this 3, this one node next reference will point to this third node. Let's see that. Here we have created the node with 3 and head node is not null, so it will go else block. Again head node we are assigning to one node which is having data 4, and next node pointing to another node which is having data 1. For this node having next reference as null. This is what we can say here, right? Now head dot next, which is head node dot next. Is it not null? Yes, it's not null, so it will go inside. Now our last node, it's basically head node dot next, which means it refer this node. So now this last node will be our second element, right? Again this while loop will execute. Now this second element will have next no, this will be false, so it will skip, and this last node dot next means this second node dot next, which is equal to new node, which is 3. Clear? We inserted 3 elements to this linked list. Like the same way we added 8. This is having 8 and next reference will be null. We have head node, so it will skip here, so head node will be assigned here. Now head node having next, so it will go inside here. Next node next reference will be second element, that will be assigned to last node. Again last node will have next reference, which is third element, so again this will be true, it will go inside. Now so this third element next reference will be assigned to last node. So basically whatever element we have added lastly, that is having null reference, right? So this node dot next will be null for this next iteration. We'll see that this is null, so it will false, it will go here, and this new node will be added here as a next. So This will be added here as the next. We have added all the 4 elements. I'm just printing that element. If you see here, it will print all the 4 values 413H, 413H. Now we'll delete element 1, this element, from this list. So basically what we have to do, right, if we want to remove this element, we'll just point this reference to third node. This is what basically we have to do, right? Let's do that in program. I'm just calling this delete by key method. I'm just pausing whatever list we have and pausing 1, means which element I wanted to delete, that element I'm sending as the second parameter to this method. See here, we need to maintain current node and previous node. You know why we need to maintain previous node? Suppose if you wanted to delete this node, right, previous node reference should point to next node, right? So if I am here, this node dot next means it will refer this one, but we want previous node to point new node, right? So that we need to maintain previous node as well. So I'm just declaring 2 variables, current node and previous node. I'm just reverting this. So we are maintaining current node and previous node. But here, right, we are going to delete this element 1, right? First we need to find this element, then only we can able to delete it, right? First we have to find. For the search operation, from where we have to start our finding? From the head node, right? Because that is our first node. From the head node we have to travel to into this linked list, then we have to find the element and we have to delete it. So I'm just assigning head node to the current node, previous node will be none. I'm just checking whether our first node is whatever we are looking for, means current node data is equal to key. If current node is 1, then we can directly delete this node and make second node as the head node. This is what I'm doing here. Current node data, which is 4, is equal to 1. No. So basically we don't want to delete head node here. Suppose here we are passing 4, then we wanted to delete first node, right? So here we will go inside list.head equal to current node.next, means whatever node we have as a second, that we are making as a head node. That's it. But here this is not the case, right? So this will not execute. I'm just going here, current node dot data is not equal to key, which means in the head node value is not 1, right? Then it will go inside whatever current node we have, that I will assign it to previous node, and here I'm just assigning next node as the current node. That's it. So again I'm checking whether this current node key is not equal to key. Actually it's false, right? Because whatever node we have currently is, that is 1, our key is also 1. 1 is not equal to 1 is false, so it will skip. So it will go this if block. Now our current node is 1, current node dot next means it's referring 3, our previous node will be head node, means first node. So here what we have to do, right, from the previous node dot next we have to refer next node, which is current node dot next node. So current node dot next means it will refer this one, and previous dot next means previous dot next means this reference will be pointed to third one, means logically we are deleting this element from this linked list. That's it. So here just we are remapping the reference, so logically it will be a delete the element 1. I'm just printing key 1 found and deleted. That's it. So basically it's deleted from this linked list. So this is the case to check whatever element I'm trying to delete which is not available in the linked list, which means I have to display whatever key I'm looking for, it's not found, to delete, right? If current node is null, means the last node reference will be null. In this case we already look for all the data, right? So whenever this will occur, right, which means basically we can't able to find the record whatever we are looking for. In that case we have to display not found. So anyway, this is not the case for this scenario. I'll just skip this. That's it. So finally I'm just printing all the elements. It should print 4, 3 and each. That's it. Okay guys, see you on the next lecture.